Hello guys, welcome to Staad tutorials. In this session we will be discussing about design and analysis of a shear wall building. So let us begin the session. Initially start Staad Pro. Select new project. Select space. Give it a name. Units be meter and kilonewton. Select next. Finish. First you go to run structural wizard. Select frame models. Select bay frame. And you can select the given dimensions. Select apply, send it to the main Staad Pro screen. Now you can see this is the first story of your building. So shear wall can be designed by using a surface element. So we will be selecting these two as surface element. So you can click this, or else you can even click generate surface meshing and can give two divisions. So let us select this. So in this way a surface is created for shear wall building. So in this way we create the surface elements. Now we'll go to general, select define, select rectangle, give size 0.4 by 0.3 for all the column and beam members, and select thickness for surface 0.2 meters. Now assign this to the entire structure having beams. Then assign surface thickness to only surfaces. You can view the 3D model. As you can see, surface created. Even you can create a shear wall building with openings. It's just that you need to select this icon and insert openings in the surface. Before that you select a surface and you need to select this icon. So you are opened up with the surface, and you can select the opening wherever you require. See, as you can see, the opening is created. You can see in the 3D model also in this way. So if we raise this building to say 10 stories, then the basic solver in Staad takes a lot of time to analyze the structure, whereas the advanced solver can do it in few minutes. However, since we have basic solver, so we will not be using a lot of stories. I will be using a shear wall with one opening, only single shear wall, and other shear walls are without openings. And I will select here all geometry cursor, selecting the whole structure. I'll select translational repeat select 3 steps. Default spacing will be 3 and in Y direction select OK. You can view the 3D model of the structure. You can go to front view. You can even select all geometry cursor and remove the top story. So you are remained with only 3 stories. Now the next thing will be we'll be going to supports, creating pinned support, assigning this pinned support to bottom nodes of the building. Then coming to loads and definitions. Well, you can basically shear walls resist earthquake loadings. So we'll define seismic definition first. We will select the code, select generate, then you will select important building, medium soil, select generate. Now select add and select self weight factor as 1, select add. You can even add floor weights, 12 kN per meter square in the range of 3 to 9 meters. Select add, close. Now selecting load case details, select earthquake load, X positive direction, give loading type as seismic. Then the next one will be selecting earthquake load, Z negative direction, and the third one will be dead load. Select add, close. Select earthquake load in positive X direction, select seismic load, factor will be positive and select add, close. Select earthquake load in Z negative direction, select seismic loads, factor will be -1 in Z direction, select add. Select dead load, select add. First will be adding self weight, then we'll add floor load directly, -12 kN per meter square in the range of 3 to 9 meters. Select add, close. Now assigning this self weight to the entire structure and that would be suffice. Now going to design tab, select concrete, select IS456. You can even select IS13920. Select IS456, define parameters, FC will be 30,000. Select add, F5 main will be 415000, select add. Now then add commands, design beam, design column, then take off. So We'll just delete this command and once again add. Now you can assign beam command to beams parallel to X and Z direction only. Make sure you do not select assign to view since it gets assigned to all the beams. Now once we are done with the concrete design, we select the shear wall tab, select code IS456, define parameters FC as 30,000 kN per meter square, select add, select F5 main 415000 kN per meter square, select add, then give command shear wall design, select add, close. Now just go downwards and assign FC to the entire structure, to only shear walls, and then Fy main will be assigned to only shear walls and design shear wall will be assigned to only shear walls. Once you are done with this, you can go to analysis and print. You can select mode shapes, then you can go to post print. You can define commands, analysis results and joint displacement, member forces, support reactions. To get all those displacements, forces, member forces, the forces in each member, support reactions, reactions at support, only to bottom nodes it is assigned. So now analyze, run the analysis. This might take time since it is basic solver. As I already said, advanced solver can easily solve building so surface 25 does not exist. Okay, since we have deleted a surface entirely, we just need to make few corrections. Well, you can see so let us check out once again. You can see member properties 1 to 195 and surface properties 1 to 32, so we will just change it to 24. and surface constants material list will be 1 to 24. So that would suffice. Select save. Now run the analysis. Well, this type of buildings, a lot of errors exist, so you make sure that you have designed it precisely without any errors left over. So you can see when modulus of elasticity is missing, what you'll do is you'll select all geometry cursor, you'll renumber it, then you will renumber the members, fine. Now let us see. Okay, so you need to close this. There even might be an error once again. So if even an error exists, you never give up on the problem. You just keep digging, you check out where you have gone wrong. See, there is another error, elastic modulus not entered for shear wall number 24. So let us go to geometry, select surface thickness. Well, surface thickness is provided for all those members. You can even select here. Okay, material concrete list is 1 to 23, select 24. That would be enough. Now analyze. As I said, errors keep on coming, but you should never give up to be a perfect structural engineer in this case. So you can see here is the basic solver being used. If it was advanced, it would have been solved by now. This is surface cursor, plate cursor, and this is surface meshing, where you can select directly all those two, and even if you want plates on the roof floor, you can select fill floor grid. You can even provide load combinations after giving the load cases. You can create the auto combinations for Indian code. They have been already provided. So this is a front view. The rectangle property is prismatic property. You can even provide a new material using user defined table. The density, elasticity, Poisson ratio are provided for the materials. These are support specifications, different types. Spring also. Member specification includes cable. As I said, this takes time. I would like to quote you, patience is virtue for everything. So we are done. Well, first we'll be going to output file. Let us see the shear wall design. Going to results, you see concrete design provided for columns and beams. Then coming to shear wall design. Well, you see shear wall design. So here it is. Okay, the one thing we have done mistake is in during defining parameters for shear wall, you need to define one more parameter, that is two layered, since single layered is not provided. Okay, so we have to go through it once again. Assign it to the structures, surfaces, run the analysis. That was a foolish mistake. Well, I would suggest you to just wait, as there is no other work we can do. So the shear wall with holes does take lot of time to analyze when compared to shear wall without openings. As you can see, 17 is a shear wall with opening. Now we should get our output file for shear walls design. So go to output file, select results, select shear wall design. Okay. You can see even the frequency factors are given. Okay, as you can see, there isn't provided a double layered here. However, I can show you a shear wall design with openings, without openings. Well, let us go to post processing for results. So you see, shear wall reduces the deflection due to earthquake loads. So such the reactions can be obtained. Well, then let us go and see a shear wall building in the output file. So you can find it, a shear wall building in there. So that is a shear wall building. Well, let us see if we have results for this. Okay, we do have results. Let us go to output directly and view the results for shear wall design. See, in this way the result for shear wall design is provided. You can see at each level horizontal and vertical reinforcement is provided. You need to just add the double layered option along with FC and FY main. Okay, let us see if we can find a shear wall building with an opening. So here it is a shear wall building. However, I don't think so that there are results for this building. Okay, so there are no results. There is error occurring. solver because it took a lot of time to solve. Let me see for another file. Okay, let us open this one. In this you can find the results for shear wall with an opening. So you can see this is a shear wall with opening. Additional reinforcement required along the sides of an opening because to avoid the shear effects as well as torsion effects. So in this way shear wall is designed. And this is the design and analysis of a shear wall is also carried out. So this will be the end of the session. You try to do it for the 3-story building. Just do not forget to mention, as I will show you in design tab for shear wall design. You need to give the Indian code and FC 30,000 will be provided, and FY main 4y5 000 kilonewton per meter square, and 2-layered structure surface should be provided. Just don't forget it to assign. So this is the end of the session. For more videos, subscribe to the channel. Thank you for watching this video.